Hello students, welcome to another video, that is the last part of your application of derivatives. So in this video we shall discuss about a few problems. There is the important one from the exercise 6.5. So let us see the first one. Here it is given question number 17. So it says that a square piece of tin of side 18 centimeter. So here I have drawn a square piece of tin, a tin of side 18 centimeter, is to be made into a box without top. So I hope you have understood that I need to make it a box like this without a top. Okay, that means this side we shall use the tin in these portions, in the bottom as well, in all the sides except the top. Okay, and by cutting a square from each corner and folding up the flaps to form the box. It means we need to cut these corners equal size squares, and then we shall fold the box from this part. So this will be our bottom, and these four rectangles will act as the sides of the square. Okay, so the question is, what should be the side of the square to be cut off so that the volume of the box is the maximum possible? So we need to find that what should be the minimum, or what portion of the box of the square should be cut off so that our box that we are going to make should have the maximum volume. Okay, that means our function will depend on the volume, and we shall find the maximum volume by using the second derivative test. So let us see here. Let us consider that the box we are going to take out is x centimeter, or let the portion to be cut out, or let the square portion to be cut out has length and breadth of x centimeter. Fine. So if it is x centimeter, that means all the sides will be x centimeter because these are squares. So if this is x, what about this length? Our total length is given 18 centimeter. So if I am considering this square as of side x centimeter, this square x of side x centimeter, so x plus x will be twice x. So the remaining portion will be 18 minus twice x. Similarly, it will hold for all the other sides. Fine. So therefore, length, or just right side of the tin of the square to be formed will be 18 minus twice x centimeter. Fine. Okay. Now the question is, what should be the side of the square to be cut out so that the volume of the box is maximum possible? Now here we are talking about this box, and we need to maximize its volume. So if you want to maximize its volume, so let us see what is volume, and let us consider the function as Vx. So how to find the volume of a box? Length into breadth into height. So what is our length in this box? It is 18 minus twice x centimeter. What will be the breadth? It will be 18 minus twice x centimeter. This is our length, breadth. And what about the height? See, we are going to fold, suppose this portion. So then if we fold this portion here, so this will, x will be the height, isn't it? So here this will be the height. Now what does this give? This gives us 18 minus twice x whole square into x. So this is our function. Now to maximize it, what we have to do? Take the first derivative of it. So we shall have 2 into 18 minus twice x, the derivative of the first function, into minus 2 here, and into x, plus the derivative of the second function. Keep the 18 minus twice x intact, and take the derivative of x with respect to x, so it will be 1. Then next take 18 minus twice x common, so we shall be remaining with 18 minus twice x, this one, minus 4x. So this will give us 18 minus twice x into 18 minus 6x. Fine. Okay. Now we shall find the second derivative. What will be the second derivative? The second derivative here will be, that is v of x, second double derivative of x. So this is our first function, second function. So 18 minus twice x, first function derivative of second function will be minus 6 here, plus second function 18 minus 6x into derivative of first function, that will be minus 2. So this will give us 18 minus twice x, or no, sorry, this will give us, you can take minus 2 common, yeah, minus 2 common, so it will be 3 into 18 minus twice x plus 18 minus 6x. This will give us 2 into 1854 minus 6x plus 18 minus 6x. So this will give us minus 2 into 54 plus 18, 12, 5, 6, 7 minus 12x. So just keep the Vx here. Let me write it. Vx will be equal to 18 minus twice x whole square into x. So this is our Vx here. I am keeping it here. And thus this gives us, let's take the 12 out, it will be minus 24. So I can take the x inside, x minus 6. Okay, fine. So we have got the first derivative and second derivative. Now what is our task? To find the critical point. To find the critical point, what we need to do? We need to equate the first derivative to 0. So now v dash x is equal to 0 will imply what? 18 minus twice x into 18 minus 6x is equal to 0. So if that is 0, this will give us 18 minus twice x is equal to 0, or 18 minus 6x is equal to 0. So from here what we get, x is equal to 9 or x is equal to 3. Fine. These two are the critical points. Now the question is, at x equal to 9, what we get? If x is 9, that means if the height is 9, or if you can say this length is 9, then our total length is 18, isn't it? Of the tin, total length is 18. So if we cut this portion 9 and this portion 9, 2 squares, or if this is the whole tin, and if all these portions are cut 9, 9, 9, 9, of the side 9 squares, then what about the square that we want to form? The length and breadth will vanish, isn't it, of the main square that we are going to form. So we cannot take this value. Therefore, at x is equal to 3, what is happening? F of, or v double dash at the point 3 will give us, it will be 24 minus 3 minus 6. So it will be 24 into minus 3. So there is a negative value, isn't it? So our function is maximum at the point 3. We have got from here because it is less than 0. Therefore v is maximum at the point 3. Okay, and what is the value of v3 will be? What is, where is our v? Yeah, here is our v. So it will be 18 minus 2 into 3 whole square into 3. So 18 minus 3, 2 is 6 whole square into 3. So that will be 6, so 18, 12, 144 into 3. So if we multiply it, it will be 4, 3, 12, 2, 4, 3, 12, 3, 1, and 3, 1, 3, 4, 3, 2. Okay, centimeter square. So this is the volume of the main square, but we are not interested in that part. Our basically we want to find the, what should be the side of the square to be cut off. When we want to find the side of the square, this, so what is the square? Side of the square, it is x equal to 3. Therefore side of square to be cut off will be 3 centimeter. So this part is not required actually, this part. Fine. So that is the answer. So now we have question number 23. It's a very important question for your exam as well, and to understand all the concepts of application of derivatives. So here we want to maximize the volume of a cone that is inscribed inside a given sphere having radius capital R. So here I have drawn the sphere with radius capital R, and this is the cone here. So if I draw the cone separately, this is the cone, and the cone is of height h, fine, and this is the radius small r. So let us consider OB is equal to x. This OB is equal to x, fine. Now what will be h from the figure? If you say what will be the height, the height I can separate it, that this portion plus this portion, that is capital R plus x, that is AO plus OB, isn't it? So this is our height, give it equation 1. And from triangle OBC, what can I say? Using the Pythagoras theorem, here this is a right angle triangle, so OR square will be equal to OB square plus BC square. So what is our OR square? It is not OR, it's OC square. So this R square is equal to, in place of OB I can write x square, and in place of BC I can write small r square. So now I want to find the radius of the cone. So R square will be equal to capital R square minus x square, and that will be given by R is equal to root over R square minus x square. So give it equation 2. So you have got the height of the cone and the radius of the cone. Now we want to find the volume of the cone from this. So if V is the volume of the cone, so V of x will be 1 by 3. What is the volume of the cone? 1 by 3 pi r square h. So 1 by 3 pi, in place of r it will be root over r square minus x square whole square into h, and that will be equal to 1 by 3 pi r square minus x square into h, fine. Okay, one more thing, in place of h I can simply write r plus x. Fine. Now what to do? We want to maximize this volume, isn't it? So if you want to maximize this volume, at first we need to find the first derivative and equate it to 0. So finding the first derivative, v dash of x will be 1 by 3 pi is constant, so keep it as it is. And now derivative of first function will be this part will be 0, so it will be minus twice x into second function plus second function into derivative of first function. So it is constant, it will be 1, so up to this. Now this will be equal to 1 by 3 pi. From this 2 I can take r plus x common, so I will be remaining with r minus x minus twice x. This will give us 1 by 3 pi r plus x r minus thrice x, fine. Okay, so we have got the volume of the cone, this, and the first derivative as this. Now what will be the second derivative of x? It will be, keep the constant separate, 1 by 3 pi, then first function, differentiate the first function, that is it will be 1 then into second function minus thrice x plus second function, derivative of second function into first function, that is minus 3 into r plus x. So this will give us 1 by 3 pi r minus thrice x minus thrice r minus thrice x. So I can just omit this one. This will give us 1 by 3 pi r minus thrice x will be minus twice r minus thrice r will be minus twice r, and we shall have minus 6x here. So this equal to 1 by 3, I can take the minus 2 common outside, so minus 2 by 3 pi r plus thrice x. So this is our second derivative. Now to find the critical point, what we need to do? We need to equate the first derivative. Now f dash x equal to 0 implies 1 by 3 pi r plus x r minus thrice x equal to 0. So if that is 0, let me write the vx here. It will be 1 by 3 pi r square minus x square into r plus x. So if that is equal to 0, from there I can write r plus x into r minus thrice x is equal to 0. So we have two conditions, either x equal to minus r or x is equal to r by 3. Fine. So you have two options. So the first thing is, can x be minus r? Can x be minus r? What is x? X is a distance and r is a radius, so it cannot be minus, isn't it? It cannot be negative. So this value fails. So we have a critical point, that is x is equal to r by 3. So now we need to find the second derivative at this point. So our second derivative is this, therefore v double dash at the point r by 3 gives us what? Minus 2 by 3 pi r plus 3 into r by 3. So yeah, this will be minus 2 by 3 pi, so 3 r, it will be twice r. So no need to do more, just you can see this is a negative value, so this will be less than 0. Therefore we are getting the maximum value of the function v at the point r by 3. Okay, so our this will be maximum when x is equal to r by 3. Okay, fine. Now what to do? We have got the maximum value at the point x equal to r by 3. So using the r by 3, let us find the h first. From equation 1, if you recall, from equation 1 what we had, our height was capital R plus x. So now in place of x I can replace it by r by 3. So this will be 3r 4r by 3. And what will be our radius? Our radius was root over, if you take this, it will be root over r square minus x square. So in place of x square, if you replace it by r by 3 whole square, so it will be r square minus r square by 9, and that will give us, here we shall have 3, so that will give us 9r square minus r square, and that will be equal to root over 8r square by 3, or I can write root 8 r by 3. So this is our height and the radius. Okay, so therefore since we have got the height and the radius, the volume will be, the volume of a cone is given by 1 by 3 pi r square h. Now what is r square? What is our r? It is root 8 r, so it will be 8 r square by 9, and h is 4 r by 3. So this will give us, now we want to equate it to the volume of the sphere. So what is volume of a sphere? It is given by 4 by 3 pi r cube. So we have a 4 here, write the 4 by 3, we have the pi here, r square and r gives us r cube. So this is the volume of the sphere, and along with this, what are the things remaining? We have a 8 here, and 9 into 3, 27. So therefore we can say that if I consider the volume of the sphere as v1, then this is equal to 8 by 27, that is v. So we have proved that the volume of the cone is equal to 8 by 27th of the volume of the sphere. So that will be the end of this problem and also the end of this video. So this is a very important problem for your exam as well as for understanding the concepts of application of derivatives. So please go through all the problems that I have given in the PDF and the videos, and solve the exercise problems. Those will be very important for you. So till then, stay home and stay safe.